Okay, hi everybody. This is a tutorial video for first year full-time Maths for Managers and first year part-time Business Maths 1. Okay. And what I'll be doing here is I'll be going through an exam question from a previous year. It's the 2019 paper for Business Maths 1. It's question 3. This question is also relevant, as I said, for Maths for Managers as well. We'll have a look at how to do this. So we'll get rid of this sheet too because the pen soaked through. Let me read out the question for you here. Okay, so it says a small printing company wants to investigate the link between the years of service employees give to the company and their hourly pay rate. The information for 6 employees are shown in the table below. So there's the time spent in the company, which is their years in service. It's X here. And there's the hourly pay, Y, 25, 20, 21. These are our hourly pay in euros. And this first row here indicates one person. He's been working, or he or she has been working for 5 years. They have an hourly pay of 25 euro an hour. Okay. And they think that there is some kind of link or correlation between these things. Okay. So the first thing I want to notice is that I have 1, 2, 3, 4, 5, 6 different people. So n equals 6 is my sample size, and that's an important number that I'm going to need to refer back to. Okay. So let's talk about correlation and how we show correlation. Okay, so we need the correlation coefficient. Sorry for my terrible handwriting. Correlation coefficient. Okay, so the correlation coefficient is lowercase or, which is this formula that I gave you before, s of x with y. I have s of x with x multiplies s of y with y, and I take the square root of everything on the bottom. And there's a formula here for each of these things. We'll talk about them in turn. We'll talk about the 3 ingredients. The first one is s of x with x. And the formula for s of x with x is that it's the sum of the x squareds. And then we take away n times the mean for x to be squared. Okay, so I need to work out my mean for x. Okay, so what is x bar? Well, x bar is the sum of the x's over n. Okay, and in this case, the x's are 5, 3, 4, 10, 17, and 15. So I have 5 plus 3 plus 4 plus 10 plus 17 plus 15. That must get divided by the number of points, which is 6. We can do that on a calculator. 5 plus 3 plus 4 plus 10 plus 17 plus 15 equals 54. So that's 54 divided by 6, and 54 divided by 6 is 9. Okay, it goes in evenly. So that's my x bar. Okay, which is a relatively straightforward computation, something we've done a bunch of times already. Okay, next step is for me to get the other part of that formula, which is the sum of the squares. Okay, so how do I get the sum of the squares? Well, this was the sum of the x's, 5, 3, 4, 10, 17, and 15 all added together. I'm going to do the same thing, except this time I'm just going to square each of the numbers. So I have 5 squared plus 3 squared plus 4 squared plus 10 squared plus 17 squared plus 15 squared. And I apologize for my horrible handwriting. So 5 squared plus 3 squared plus 4 squared plus 10 squared plus 17 squared plus 15 squared. And that's 664. So that means that s of x with x, writing down the formula again, that was the sum of the squares minus n times the mean to b squared. And that's what? Well, this is this number here. Sum of the squares is just the number. Sum of the squares is just the number I worked out. So that was 664 here. Then I have 6 was my number of points, and I had my mean, which is 9. That gets squared. And now on my calculator, 664 minus 6 times 9 squared equals, and that's 178. Okay, 178. So that's the first part done, s of x with x. I also need s of y with y, which is what? S of y with y is the same formula as s of x with x, except that I have y's instead of x's. So it's the sums of the y squareds minus n times the mean for y squared. Okay, so I want my mean for y, which is the sum of the y values divided by n. And now I need to check my y values, which are on my table here. 25, 20, 21, 35, 40, and 38. And that has to get divided by n, which is 6. Okay. And if I do this here, I have 25 plus 20 plus 21 plus 35 plus 40 plus 38, which is 179, and I need to divide that by 6. And this is going to be a little bit awkward here because we can see that I have a recurring decimal, and I really don't want to cancel that too quickly. I don't want to truncate that up to like 29.8 or something like that. The decimal places there might actually be important. So I'm just going to write this for the moment as 179 divided by 6, okay? Which is about equal to 29.83 recurring, okay? Okay, so now that's the mean for y. I also need the sum of the y squareds, which is pretty simple and straightforward again, okay? So the sum of the y values squared is what? I'm going to have 25 squared and 20 squared and 21 squared plus 35 squared plus 40 squared plus 38 squared, which is what? Again, calculator, 25 squared plus 20 squared plus 21 squared plus 35 squared plus 40 squared plus 38 squared. Answer 5735. Okay, and now I'm able to find my answer for s of y with y, which is what? S of y with y then is going to be the number I just worked out, the sum of the y squareds minus n times the mean for y squared. And I'm going to include a fraction here again just to make sure everything works out and I don't have a truncation error that I might regret later. Okay, so what do I have? The sum of the y squareds, that was 5735. I'm going to take away here, and I have 6 times 179 over 6, and that term there has to be squared. Okay? Which I can make a little bit simpler in this case, actually. There's 2 6's on the bottom here, 6 times 6 on bottom. There's a 6 on the outside, so that's going to be 5, 7, 3, 5. And this is going to be minus 179 squared over 6. Okay. Okay. So I have 5735. 5735. I'm going to subtract away 179 squared over 6. And that number is 394.83, which is 2369 over 6. So I'm going to write that as 2369 over 6. Okay. Which is about the same thing as 394.83. And again, that's a recurring decimal place, so I want to avoid truncating too soon. Okay? So I've worked out my s of x with x, I've worked out s of y with y. Let me just indicate my answer for s of x with x here. That's the important information for x. This is now my important information for y. And I have one more that I want, which is s of x with y, which is the sum of the products, x and y, minus n times the mean for x and the mean for y taken as a product together. Okay, so the first thing I want is the sum of products. Okay, the sum of products. So I'm just going to pull out the original data here. I'm going to need to multiply 5 by 25, 3 by 20, and so on. The sum of the products, x times y, is 5 times 25 plus 3 times 20 plus 4 times 21 plus 10 times 35 plus 17 times 40 plus 15 times 38. Okay. Calculator here. 5 by 25 plus 3 times 20 plus 4 by 21 plus 10 by 35 plus 17 by 40 plus 15 by 38 gives me my answer, 1869. Okay, 1869. And now s of x with y is what? Well, it's this sum of the products minus n times x bar, y bar, my means. Okay, so that's the number I just worked out here, 1869. N is 6. My mean for x, if I go back here, we'll see that my mean for x was 9. And now my mean for y was 179 over 6. So 179 over 6. Like that. Okay. We can see that there's a cancellation here, which makes things a little bit easier. That 6 is going to cancel with that 6. Okay. So we just have 1869, subtract away 9 by 179, and what do I have? I have 1869, subtract away 9 times 179, and that answer is 258. Okay, we'll underline that as well. So this answer is this. Okay. So I am just about ready now to put all of my information together in the required fashion. I'll just recall the formula here. The formula is that OR is equal to S of x with y. On bottom I have S of x with x, which gets multiplied by S of y with y. And I take the square root of all of that. Okay? So S of x with y, the number I just worked out, was 258. What do I have on the bottom? I have a square root, which I'll complete in a moment. I have the S of x with x term, which was 178, which needs to multiply here. And I'm going to use you might not like this, I'm going to use the fraction version just because I don't want a rounding error to appear. If I'm going to round, I want to do it later. I don't want to do it at the beginning. So this is 2369 over 6. Okay. And of course, a calculator can do this almost exactly in the form that I have it in here. Okay, so fraction form 258, bottom square root 178, and now bracket fraction form 2369 over 6. Okay, and that gives me an answer, and it's a decimal answer of 0.973. Okay, and I don't worry so much about the stuff after the third decimal place here. I'm not so concerned. You might wonder, why was I so strict about making sure I didn't get a rounding error? Well, you can see that this number is actually quite close to 1. Okay, and if I had been lazy and I had rounded throughout. Okay, so say for example, instead of taking, if instead of taking 179 over 6, I had just say taken 29.8, then I would have gotten a different answer for S of y with y. And if I get lazy here, I'll get a different number on the bottom, okay? And I might actually get a number which is too small. Okay, on the bottom, I might actually get a number here which is bigger than 1 if I'm lazy and I make rounding errors. So I don't want to introduce rounding errors. I want to include as much accuracy as I can throughout. Okay. Okay, so that's my OR, which is the coefficient of determination. Sorry, it's not the coefficient of determination. That's the correlation coefficient. Okay, and it says here, interpret the result obtained. So this is positive. Okay, so that indicates that there is a positive correlation. And it is close to 1, which indicates it's a strong linear correlation. Okay, it's a strong linear correlation. Now, I'm not asked for this next part here, but I'm going to include it just for the sake of completeness. Okay, if I was asked for the coefficient of determination, that would be OR squared, which would be 0.973 squared. 0.973, square it, roughly 0.947. Okay, 0.947. Or you might hear that about 94.7% of the behavior in Y is described by the behavior in X, but that's not a fully correct statement. It's kind of misleading. Okay. So the next thing we want is the regression line. The regression line is going to have the form that Y is going to be A plus B times X. Okay. And I have a formula for B. Okay, the formula for B is relatively simple and straightforward. Okay. The formula for B is now S of X with Y divided by S of X with X. Okay. And of course I have this information worked out already. Okay. S of X with Y was 258. Okay. My S of X with X, you can actually see it right here, is 178. So I have 258 divided by 178. That gives me a B of about 1.449. We'll call that 1.45. Okay, just 2 decimal places is okay. 1.45. Okay. And then we get our A in a slightly different manner. The formula for A is as follows. A is then mean for Y minus B times mean for X. My mean for Y, if we go back here, was 179 over 6. And I'm going to subtract away B, and I'm going to be as accurate as I can be. I'll say 258 over 178 here. And then my mean for X was just 9. Okay, it was a nice round number, a nice whole number, I should say. So again, my calculator can work this out. 179 divided by 6. And then I will subtract away 258 on top. Oops, sorry. 258 on top, 178 on bottom, and I'm going to multiply that by 9. Okay, and that number there is 16.78. We'll call that 16.79. Okay, so what's my form? My form is that Y is equal to A plus B times X, which is equal to 16.79 plus, and B we said was about 1.45, and then I have X. Okay, so that's my Y there. Okay, let me read out the next part of the question. The next part of the question says that a randomly selected employee has 14 years of service. Okay, this is some employee. As X is equal to 14. So now we want to predict their hourly pay. Which is Y. Okay. This is fairly straightforward to do now. I have everything I need to do this. Okay, so my formula is that y is going to be 16.79, and I'm going to add on 1.45 times 14. Okay, and of course, that's very simply done on a calculator. So 16.79 plus 1.45 times 14. And that number is 37.09. Which is in euros. Okay. And now let's look at our original table here and see if that makes sense with the information we've been given. Okay. So we've been told that their years in service is 14, which means that they're between this person here who has 10 years of service and this person here who has 15 years of service. We see that the person with 10 years of service gets paid 35 an hour. The person with 15 years of service gets paid 38 euros an hour. And the person with 14 years in service, we would expect them to be paid more than 35, which is more than the person with 10 years experience, but less than the person with 15 years experience, that is less than 38. So 37.09 looks pretty good there. Okay. Okay, so that's the entire question answered. We might do another one again tomorrow or the day after to get people comfortable with this. Again, if you have any questions, you can let me know in the comment section. See you again soon.